We're going to continue our discussion of solving equations by looking at situations that involve using formulas. Let's look at activity 2, planning for the weather. Hannah is visiting Germany from the United States. She's planning a week-long backpacking trip and wants to use the forecast in the newspaper to help her know what to pack. However, she's not familiar with the Celsius temperature scale, and since she's staying in a remote cabin, she doesn't have a reliable internet connection. She does find the following formula in her travel guide, however, to convert between Fahrenheit temperature reading F and its corresponding Celsius temperature reading C. And that formula is C equals 5/9 times the quantity F minus 32. Hannah sees that there's a high temperature of 17 degrees Celsius on Thursday and a low temperature of 4 degrees Celsius on Thursday, and the following Wednesday. Use the above formula to find the corresponding Fahrenheit readings for these temperatures. All right, so we've got the forecast down here. So we have 17 degrees Celsius on Thursday and a low of 4 right there. And then the following Wednesday. Okay, and the following Wednesday. So we want to find those temperatures as well, 2 degrees and 4 degrees. All right, we have some work to do, so let's jump in and do it. So when we have a formula like this, the most important part of any formula is knowing what the variables stand for. And this one's pretty easy. The C stands for Celsius temperature and the F stands for Fahrenheit temperature. Numbers are just random ways to express temperature, right? You walk outside and we're assigning a number to what that temperature feels like. And there's different ways to do that. We're just so used to using Fahrenheit, but we could assign any number value system as a way to describe weight or distance or temperature or anything that we want to measure. All right, so let's start with Thursday with the high temperature of 17 degrees Celsius. So since the Celsius temperature is 17, what we want to do is we want to substitute 17 into the Celsius formula. So we have 17 equals 5/9 times the quantity F minus 32. And now we want to find the Fahrenheit temperature. So this is a great example of how we can use our skills in solving multi-step equations to answer a real-life problem. Now we have two options as far as continuing here. One option is to distribute the 5/9 on our next step. Another option is to eliminate the 5/9 from this side of the equation by either dividing by 5/9 or multiplying by 9/5. I'm going to suggest that we go ahead and get rid of this by the latter, getting rid of the 5/9, or starting the problem by getting rid of the 5/9, eliminating the 5/9 from the right-hand side of the equation. So I'm going to go ahead and divide both sides by 5/9. Now remember, dividing by a fraction is the same as multiplying by the reciprocal. So 17 divided by 5/9 can be found by 17 multiplied by 9/5. So we'll do that computation. And then on the right-hand side, these 5/9 are going to reduce down to 1. So we're just going to be left with F minus 32. All right, let's perform the computation. 17 times 9/5. So we're going to do 17 times 9, which is 153 over 5. Now that's not a particularly nice number. We could go ahead and divide it. It should be a pretty nice decimal. Any fifths would be nice. I mean, when I say it's not a nice number, it's not a whole number. But fifths aren't too bad. So let's see. 5 goes into 150 30 times with 3 left over. And 3/5 is 0.6. So now we have 30.6 equals F minus 32. And to isolate that variable F on the right-hand side of the equation, our last step is to add 32 to both sides. So we end up with 62.6 equals F. So what that's telling us then is 17 degrees Celsius is roughly equivalent to 63 degrees Fahrenheit. All right, why don't you give it a try and do the conversion for 4 degrees Celsius. All right, check it out. Did you get 39.2 degrees Fahrenheit? I hope you did, because that is the correct answer. So we have a high of 60, about 63, and a low of 39 on Thursday. Now, another way that we could have solved this equation is to distribute the 5/9 first. And I just want to go through that. I don't know if maybe some of you did that. There are some pitfalls to this. Let's take a look. So if I distribute the 5/9, I get 5/9 F. Okay, no problem there. Then I'm going to do 5 times 32 over 1. So 5 times 32 is 160, and 9 times 1 is 9. Now, 160 divided by 9 is not a whole number, and its decimal is a repeating value. So this is where doing it this way is a little bit yucky, let's call it. Is that an official mathematic term, yucky? So if I do 160 divided by 9 on my calculator, I get 17.7 repeating. Now, a little factoid here is that if you have 1 digit repeating, the fractional equivalent of that is always that number divided by 9. 0.1 repeating is 1/9. 0.2 repeating is 2/9. 0.3 repeating is 3/9, etc. Now I'm going to write this as a fraction because I don't want a repeating decimal over here that I have to add or subtract. I mean, you can do it. It's not, in this case, we're adding it on. It's not that bad. But I'm going to add 17 and 7/9 to both sides. So this gives me 21 and 7/9 equals 5/9 F. Hopefully you're seeing how the other way was actually a little bit nicer. Now we have to divide both sides by 5/9 or multiply both sides by 9/5. We're going to multiply both sides by 9/5. So to do this multiplication, I want to take 21 and 7/9 and turn it into an improper fraction. So I'm going to do 21 times 9 and then add 7, and I get 196. 196 over 9. Keep the denominator the same. And I'm going to multiply that by 9/5. So the one nice thing here is that these 9s will reduce. So I just have to do 196 divided by 5. So if I do 196 divided by 5 on my calculator, I get 39.2. So you can see these two different methods of solving. In some cases, there is an advantage to doing it one way over the other. All right, let's continue on here. What do you notice about the algebraic steps in your 2 conversions from problem number 1? Explain your reasoning. Well, let's go back and look at our algebraic steps from problem number 1. These 2 conversions right here. What were our algebraic steps? Well, let's say we're not doing it this way. Okay, this was our alternative method. Let's look at these 2 methods. First thing we did was we divided by 5/9, or we could think of that as multiplying by 9/5. That was the first thing we did in both of these situations. Second thing we did was we added 32. Okay, that's what we did. So they are the same. The steps are the same. What do you notice about your about the steps? They are the same. First, we divide by 5/9 or multiply by 9/5. That's the same thing. And second, we added 32 to both sides. And when I say both sides, we mean both sides of the equal sign. And we could be specific up here that we did that to both sides of the equal sign. Or maybe on both sides of the equal sign. That's probably a better way to say it. We added 32 on both sides of the equal sign. So 3 says, Hannah would like to convert every temperature in the forecast to Fahrenheit. Do you think she should use the same approach you used in problem 1 for each temperature, or is there a more efficient way to do this? What do you recommend? Well, she's going to have to use the same steps over and over, right? So anytime we're using the same steps over and over and over again, there might be a shortcut. And let's skip ahead down here to problem 4. It's okay if you don't write anything for number 3. Because Hannah wants to know the Fahrenheit readings for the Celsius temperatures in the forecast, she can treat C as a number in the conversion formula and solve the equation for F. All right, so here's our formula. So let's pretend like C is some number, because that's what we were doing. We were plugging a number in for C. And then what do? We divide it by 5/9 or multiply it by 9/5. So let's just do that. Let's do that here with the formula without even putting a number in for C. So on this side, we're going to get C times 9/5 equals F minus 32. Because this 5/9 divided by this 5/9 will be 1. And so that will, quote unquote, go away. 1 times anything is just that number. All right, so let's rewrite this C times 9/5 in the way that we usually rewrite it, with the number in front times the variable. And then what did we do next on those problems we just solved? Well, we added 32 to both sides. So now these are not like terms, so what I have to do is just write that I'm going to add them. I'm going to take 9/5 C plus 32, and that's going to equal F. So what we've essentially done here is we've created another formula. Actually, well, it's the same formula solved for a different variable. So the two formulas to convert from Celsius to Fahrenheit are the first formula that we had at the beginning, and then this second formula that we just derived. And remember, don't drink and derive. I have to say that at least once a quarter. Okay, so now we could use either one of these formulas to do our conversions. So let's go back to the temperature readings that we were doing at the beginning and use the result from problem 4, which is our new equation, to do the same problem. So we have this new equation, this alternate equation that we created to convert Celsius to Fahrenheit. And back here, we wanted to figure out what was the Fahrenheit temperature for 17 degrees Celsius. So let's use our new formula to do that. Okay, so now we want to convert 17 degrees Celsius to something degrees Fahrenheit. We already know the answer because we did it. It was 63. But we want to show that this new formula works. So we're going to take 17 degrees and we're going to plug it in for C. Now we don't really have to use algebra to solve it because the variable that we want to know, F, is already isolated on one side of the equation. That's the benefit of this version of the formula. So we're going to take 9 times 17, which we did basically over here, right? 9 times 17, we got 153 over 5. We're going to get the same thing. And then what did we do? We added 32 to both sides. Before, this formula already has that done for us. So this is 30.6 plus 32, and we get, oh, it wants to go to the next page. We get 62.6 degrees. All right, let me write it down here. You guys do the same thing. Use this formula to do the other one we did. The other one we did was 4 degrees Celsius. 4 degrees Celsius is how many degrees Fahrenheit? So I want you to use our new formula, our alternate formula here. We already know the answer. Remember, it was like 39 degrees. I want you to use this formula to do that calculation. So pause the video and restart it when you have it. So there's the steps. You should get 39.2 degrees. So what's the benefit, right? We could get these answers using either one of these formulas? Well, the benefit is if I know the Celsius temperature and I can just plug it in here and not have to do algebra on both sides of the equation, just use my order of operations, second formula is going to be a better deal. Let's say I tell you the Fahrenheit temperature. I say, oh, it's 100 degrees Fahrenheit. I wonder what that is in Celsius. Well, then this first formula might be a little bit easier because you can just plug 100 into there, subtract 32 and times by 5/9, and you don't have to do any solving equations. You don't have to do any adding or subtracting or anything on both sides of the equal sign. Any formula that has variables is going to have different versions of that formula. As a matter of fact, it's going to have as many versions as there are variables in that formula.